This is a diode, a typical two-element electronic tube. Let's get inside it. In fundamental operation, it resembles an ordinary single-pole switch, a switch that can connect, for instance, this battery and its motor load. One power lead comes to the anode, the other lead goes to the cathode. When this switch is open, the contacts are insulated from each other by a vacuum, or by some inert gas inserted into an evacuated tube under low pressure. To close this switch electronically, all we need do is heat the cathode and give the anode a positive potential. Then here's what happens. As electrons are emitted from the surface of the heated cathode, being negatively charged, they fly at tremendous speed to the anode. In this way, a current-carrying path is formed, which closes our electronic switch and permits our motor to operate. You'll notice, by the way, that the direction of electron flow is contrary to the orthodox concept of current flow from plus to minus. In the first place, we can rectify current with it, converting AC to DC. We can do this merely by connecting an electronic tube in series with an AC circuit. As you study this circuit diagram, note that only each positive half wave of AC voltage will now produce a current. When the anode is negative, the electrons are repelled and no current flows. In other words, because only the cathode can emit electrons, we have here what amounts to a one-way street. We can visualize the result of the tube's rectifying action with the aid of these two oscilloscopes. The one on the left shows alternating current coming in. The one on the right shows pulsating direct current going out. The applications of this basic rectifying principle are many and important. The second basic thing we can do with it is amplify. Here's how. Between the cathode and the anode of the two-element tube, which we diagrammed a while ago, we now place a grid. To this grid, we connect an input of some weak voltage which we wish to amplify, perhaps that of a faint radio signal from halfway around the world. Now let's see what happens. Every time a negative potential is impressed on the grid, even though it be very minute, it has a large effect in reducing the number of the negatively charged electrons which would otherwise keep flying from cathode to anode. Conversely, when the grid is positive, an equally large effect is exerted in increasing the flow of electrons from cathode to anode. The important thing to note here is this. A small amount of power applied at the grid is amplified into a large amount of power in the anode or work circuit. This amplifying property of the three-element electronic tube is put to work in innumerable ways.